Hello everyone, I am Manali Joshi from LJ Polytechnic. Today in this session we will be dealing with numerical from bending in stress chapter that is coming in the 5th semester of architecture assistantship for the structure subject. So let us begin with our numerical. This numerical states that I have a square cantilever beam. It means our beam is nothing but cantilever over which it has a span of 2 meters. It means this span is 2 meter, carries a UDL of 28 kilonewton per meter. It means entire span is UDL, permissible stress as 7 Newton per mm square. It means my F is 7 Newton per mm square. As 7 per Newton per mm square, decide the size of a square beam. Usually we have a rectangular beam, but for this sum we have a square beam of dimension we have to find out. So over here I will suppose it as B. And because it is B and it is square section, its depth will also be B. If I divide it equally, matlab NA milega, so this will be my Y. And as per my flexure equation, I need to find out M, I, Y and F is already given. Finding moment for cantilever UDL, which will be WL square by 2. Now substituting the value which is 28 instead of 2, and because I wanted it mm, I will write 2000 square upon 2. So over here my value of m will be 56 into 10 raised to 4 Newton mm. Next I have to find out I. So I, using the formula BD cube upon 12, instead of B I will again write B into B cube upon 12. We know that we will always add this. So I get B raised to 4 upon 12. And if I bifurcate ahead, 1 upon 12 into B raised to 4. So here my I will be 0.083 B raised to 4. Similarly for Y, we have a formula D by 2. So over here, if I use B instead of D, I will get Y as 0.5 B, and we have the value of F also. So I will easily get the value of B, which will be the actual size of my square beam. Now as per flexure equation, it is M upon I equals to F upon Y. Substituting the value, M is 56 into 10 raised to 6 upon I is 0.083 B raised to 4. F is already given in the question, which is 7, and Y is 0.5 B. Now with the help of cross multiplication, we will get the value of B, which will be 56 into 10 raised to 6 into 0.5 B upon 0.083 B raised to 4 into 7. So finally, if I get the value, because over here it is B raised to 3 and this becomes 0. So here my B raised to cube will be 48.02 into 10 raised to 6 mm. Finally, if I bifurcate, my B becomes 363.5 mm. Unit will be mm. So lastly, we know that it is square section in which D is this, and instead of D, it will be the same. So my answer line will be the square section will be of size 363.5 mm into 363.5 mm. So this sum was a bit different because in this sum we have dealt with a square section instead of rectangular, a cantilever beam instead of simply supported beam, and a UDL in it. So over here our equation, that is flexure equation, was very much helpful to find out the value of B. And because it was square section, sizes will remain the same of B and D also. Hope you have understood this numerical thoroughly, and it will be very easily for you to calculate the similar types of numericals. Thank you for watching.